Harpios is probably my favorite small monster in wilds because it combines so many interesting traits from birds, predatory fish, and pterosaurs. The general body plan of Harpios, where it walks on its wings and has these little teeny tiny legs that sit under its body, as well as a long bony tail, initially seem very pterosaur-like, as do these teeth. The big head crest is also very reminiscent of a lot of pteranodonted pterosaurs, which are the most well-known ones for their diving behavior. However, Harpios also has this super bizarre beak structure on its face that is very reminiscent of the Ramphotheca of a bird. This is Rosemary, and she's my daughter. Now, the Ramphotheca is the sort of keratin sheath that sits over the upper and lower jaw of the beak of birds. The main reason that all birds that are around today have Ramphotheca and not true teeth is because the birds that did grow true teeth died out at the end of the Mesozoic, and the ones that had the Ramphotheca are the only ones that stuck around. This is the beak of a common merganser, which is a kind of fish-eating sea duck. And you can see here, even though these are not true teeth, the bill has basically converged into the shape of a long, toothy jaw with, fairly similar teeth to what we see in fish-eating animals. The teeth of most fish-eating animals, like this Ganges gharial, which is a fish-eating reptile from India, are short, round, and not serrated, which is the same condition that we see in the Harpios. It's also what the projections on the red-breasted and common merganser's bills look like. Another really interesting thing about the Harpios in regards to its similarities to birds are its feet. Most of its body is shiny and scaleless, and I'll get to the explanation behind that in a little bit, but the feet themselves are covered in these scutate toe scales. If we take another look at our European starling over here, you can see that there are these kind of broad and flat scales covering the tops of the toes, and then you have smaller ones underneath. And that's a condition that's fairly common across a lot of groups of reptiles, but it's most ubiquitous in birds. Just about every bird has those scutate toe scales. Those same toe scutes are actually present in the fossils of a lot of non-avian dinosaurs, which gives us a pretty solid idea that the bird's extinct relatives probably also had similar sort of patterns and layouts of the scales on their feet. Harpios has 4 toes on each foot, and this inner one is not clawed, and it's usually held off the ground, so it's kind of vestigial. These toes are also webbed, which enables it to move through the water with greater efficiency. This is a largely aquatic animal. Its behavior is quite analogous to that of a diving bird. Onto the front limbs, and this is where we start to see some major similarities with pterosaurs. Harpios, much like pterosaurs, has a main wing that is suspended by the pinky finger. It has this sort of long, extensive membrane that comes around here and then attaches to the hips. You can see it much better in this screenshot, but the membrane starts here at the hips, right behind the legs, and then comes up and then attaches to this, which is the pinky finger of the Harpios. Now, there is this great big slot that runs up the wings of the Harpios and separates the main wing membrane into 2 sections. The upper section of the wing is suspended by the 4th finger, which for us would be the ring finger, and it creates this sort of sticking out section in the front that allows for better air control. In birds, this is analogous to a part of the wing called the alveola, which is a series of feathers attached to the thumb that allows for better control of airflow over the wing and acts as like an airfoil or a stabilizing flap. That makes the birds have an easier time preventing themselves from stalling in the air, and they can slow themselves down faster in time to land, which Harpios probably uses its wing membrane in a similar way. That's not the only membrane on the body, though. Harpios also has this one behind its head and this one on its tail. Now, these membranes that stick up and down might act as rudders, either in the air or the water, and allow the animal to turn or stop faster. I came to this conclusion because when you watch Harpios fly, whenever it turns, it sticks its tail in the direction that it's turning into, which slows down the flow of air this way and allows air to pass faster this way, which, slows down this side of the body and speeds up this one. So much like the rudder of a boat, Harpios' tail is allowing it to turn faster in the air. The structure on the head doesn't seem to be as articulated in terms of left to right movement, so it might just be a stabilizer, but it is also attached to the muscle of this gigantic fin ray that sticks up behind the head. The head of Harpios. And it's not static by any means. It's not fused to the skull. It's attached to this joint right at the end of the cranium. And as I'm sure some of the more observant folks among you have noticed, Harpios can use the musculature of its skull to pull this fin ray forward and have it act very similarly to the rostrum of a swordfish, which it uses to then skewer fish, just like a swordfish would. Harpios' coloration is also very similar to what you would expect from a large aquatic predator like a swordfish, with it being dark on top and much lighter on the bottom. This is something that is very common in both aquatic and aerial predators and prey, and it's called countershading. Particularly because when you're underwater or in the sky, when you're looking up, you almost always see the sky, the clouds, or the sun, and when you're looking down, you see the dark ground. And that allows these animals to be very well camouflaged just by having a relatively simple color pattern. Harpios in particular is quite interesting because, as I mentioned previously, it's almost completely scaleless outside of its feet and hands, which are kind of this blue and then yellow shift depending on where on the body you are. The scaleless parts of Harpios are the shiniest ones. And this scalelessness could be very plausibly an adaptation for better speed in the water, because having rough skin, unless it's very highly specialized, is going to slow you down by catching drag. And this coloration is very reminiscent of a large aquatic predator called the cutlass fish. More than just the coloration and scalelessness of the Harpios seems to be inspired by the cutlass fish, though, because as you can see here, they have a very, very similar shape to the lower jaw. They have this kind of projection that sticks out at the bottom, and then the upper jaw has a notch in it called a diastema. Harpios, again, has a rhamphotheca that sticks out at the bottom here, and then they have this little gap in the upper jaw that slots into that gap in the bottom jaw. So I can say the cutlass fish was absolutely an inspiration for the design of Harpios when they were doing this sort of thing, which is very cool to be able to notice because they clearly did their homework of having a shiny, scaleless predator that would move through the water with an iridescent skin that kind of automatically countershades when you're at a certain depth. In fish, the shininess of the scales, and in scaleless fish, the scaleless parts of the skin, is due to the presence of guanine crystals in the integument. Integument is like a fancy word for the skin and the stuff that sits on top of it. Now, this is kind of an under-researched topic, so I can't say for certain if Harpios has guanine in its body, but I think it's probably the most likely explanation given that its skin and texture is so similar to that of cutlass fish and other large predatory fish like tuna. Another cool thing about Harpios is this stripiness that it has all over its body. One of the coolest things we know about predatory fish and their stripiness is that some species of billfish, which are, swordfish, marlin, sailfish, that sort of family, can actually change color, and they do it to communicate with each other while they're hunting. As you can see here, these guys can really rapidly change from having a striped pattern on their body to being relatively dull. And while this isn't animated or illustrated in game in any way, I like to imagine that Harpios might do a similar thing because of all the structural similarities in its body. So that's a little bit of speculation, but I think it's fun. So yeah, that's a little bit of a explanation of all of the different features that we see within Harpios, a particularly bizarre small flying wyvern found in the oil well basin and the forests, as well as an appearance from my daughter, Rosemary, who is a taxidermied European starling. Please let me know if there's any other monsters or creatures or endemic life or anything like that that you'd love to see in this series, or if you have any questions about ecology or evolutionary biology or any sort of stuff like that. I'm always happy to answer them.